Okay, this video is on long division of polynomials. So looking at example 1, what we need to look for is that my first thing right here, that it's in standard form, meaning my exponents are descending, so I have x squared, x, and a constant, awesome, and that I'm not missing anything. So again, x squared, x, and a constant. If it just went x squared and then a constant, I'd have to add in a 0x. So I cannot be missing any terms in between. So if I have that, I can just start dividing. So this is the same thing that we've done in elementary school, except now we have variables with it. So I get 15x squared plus 8x minus 12. Then I have 3x plus 1. So whatever comes first goes on the inside. What comes second goes on the outside. So here we go. What do I need to multiply 3x by to get 15x squared? Well, 5x. So I take 5x and I multiply it by 3x. I get 15x squared. Then I do 5x times 1. 5x times 1 is a positive 5x. From here, I draw a line. I change my signs. So my signs become negative. And then I combine like terms. So 15x squared minus 15x squared cancels out. 8x minus 5x is 3x. And then I bring down my next term, negative 12. From here, I have to think, what do I need to multiply 3x by in order to get 3x? A positive 1. So I take 1 and I multiply it by 3x and I get 3x. I take 1 and I multiply it by 1, I get a positive 1. From here, I draw my line, I change my signs. So now what we get, 3x minus 3x cancels out. Negative 12 minus 1 gives me a negative 13. This is known as my remainder. Okay, so how I write my answers, I have what's up top, 5x plus 1. Then I have my remainder. It's negative, so I have minus 13 over what I divided by right here, 3x plus 1. And this is my answer. Looking at example 2, same thing. But on this example, I noticed that I don't have it in standard form because I have an x squared first, but my highest degree is at 3. So I need to rewrite it. So 2x or 2y cubed minus y squared. And after y squared should come a y, but I don't see that I have a y. So I'm going to go ahead and add that in, plus 0y, because we can't be missing anything. And then a positive 25. So again, I wrote it in standard form where my y cubed comes first, and then I added in a 0y because it was missing. And it's still being divided by y minus 3. From here, I draw my little division house. 2y cubed minus y squared plus 0y plus 25. And then I have y minus 3. So I ask myself, y times what gives me 2y cubed? Well, 2y squared. So I multiply 2y squared times y, I get 2y cubed. 2y squared times a negative 3, I get a negative 6y squared. From here, I draw my line, change my signs. I circle it so I know that I changed my signs. Okay, from here, let's see. 2y cubed minus 2y cubed cancels out. That's what we're looking for. Negative y squared plus 6y squared is 5y squared. And I bring down my next term. So plus 0y. So now I look, what do I need to multiply y by to get 5y squared? Positive 5y. 5y times y gives me 5y squared. 5y times a negative 3 gives me a negative 15y. So from here, wrong color. Draw my line, change my signs. 5y squared minus 5y squared, I can't talk, I'm sorry, cancel out. 0y plus 15y is 15y. I bring down my next term, plus 25. So now I ask myself, what do I need to multiply y by in order to get 15y? My self tells me it's 15. 15 times y is 15y. 15 times negative 3 is a negative 45. Draw my line, change my sign. So from here, let's see, 15y minus 15y cancels out. 25 times 4, or not times, I'm sorry, 25 plus 45 is 70. Again, this is my remainder. So to write my answer, I have 2y squared plus 5y plus 15 plus my remainder, so I do 70 over y minus 3. Ta-da! And if you notice, my answer is 1 degree less than what I started with. So I started with a cubic and went down to a quadratic. Example 3. Although this looks different, this is the exact same questions we've been doing. A fraction is a division problem. But if you notice, I'm missing a term, so I need to write that in before I start. Okay, so I have x to the 4th, but I'm missing that x cubed term. So I add that in, plus 2x squared minus 5x plus 2. It's all divided by x plus 2. So I'm going to divide like I've been doing. So x to the 4th plus 0x cubed plus 2x squared minus 5x plus 2. And I get x plus 2. Woo! This one has a lot of work to do, but it's the same process every single time. So x squared times what gives me x to the 4th? X cubed. So I multiply, I get x to the 4th. X cubed times 2 gives me a positive 2x cubed. From here, draw the line, change the sign. So if I look, my x to the 4th minus x to the 4th cancels out. 0x cubed minus 2x cubed is a negative 2x cubed. Bring down my next term, plus 2x squared. So what do I need to multiply x squared by to get a negative x, or negative 2x cubed? Well, let's see. A negative 2x squared. So negative 2x squared times an x squared gives me a negative 2x cubed. A negative 2x squared times 2 gives me a positive 4x squared. From here, draw the line, change the signs. Oh, that should have been a negative, but it turns into a positive. Okay, I'm sorry, making mistakes. So what happens here? Let's look. These cancel out. 2x squared plus 4x squared gives me 6x squared. And I bring down my next term, negative 5x. So self. What do I need to multiply x by right here, that x, to get 6x squared? My self tells me it's 6x. I'll trust them today. 6x times x gives me 6x squared. 6x times 2 gives me a positive 12x. Make sure I don't mess up on my signs this time. Oh, wrong color. Draw my line, change my signs. So it's now a negative 12x. Those cancel out. Negative 5x minus 12x gives me a negative 17x. And I bring down my next term, plus 2. So let's see. Self, what do I need to multiply x by to get a negative 17x? Just a negative 17. Negative 17 times x is a negative 17x. Negative 17 times 2 is a negative 34. Making sure I don't make any more mistakes. Draw my line. Change my signs. Negative 17x plus 17x cancels out. 2 plus 34 is 36. Guess what 36 is? My remainder. So my answer, x cubed minus 2x squared plus 6x minus 17 plus my remainder of 36 over x plus 2. And this is how you divide polynomials using long division. Tomorrow we will learn how to use synthetic division.